Actually, these are the start of the 1E notes. So this is solving systems of equations by graphing. So let's start out with some notes, some visuals, what we're going to need. So types of solutions. We have one solution. This means if you have two lines, anywhere along that first line that I just drew, there's an infinite amount of solutions to that equation of that graph. So anywhere along the line. If I draw another line, the blue line there's an infinite amount of coordinates along that graph that are solutions to that equation that represents that graph. Where they intersect, that is the solution to both, because that coordinate lies on both of the graphs. So that'd be our one solution, and the solution would be represented with a coordinate, x and a y. Now to have a no solution, we would have something like a line, so very similar to the first, but our second line would actually be parallel. They will never intersect. So they have the same, if you're looking at the equation, they're going to have the same slope, but different y-intercepts. So those are the two things. They're going to have the same slope, but different y-intercepts when you're looking at the equation. That'd be a no solution because they never intersect. Well, now you're thinking, well, what about infinite solutions? Infinite solutions, we're going to have two graphs. So again, you'll have a graph. Let's say something like this. So there's your first equation, or a graph of the representing an equation. And our second one actually is right on top. So if they intersect each other all the time, that's going to be infinite solutions. They're always touching each other. Anytime they cross or touch, that is a solution. So that'd be infinite solutions. All right, let's move on to number one. So I want to graph the first one. For these, every equation, we're going to get it into a slope-intercept form. We're going to solve for y. Make sure the equation is solved for y. Well, the first equation already is y equals. So therefore, we can tell what our y-intercept is. It's -2, so I'm going to go down on the y-axis to -2. And then our slope, so our b is -2, and our slope is 1/2. This means up 1 and right 2. So we're going to go up 1, right 2, up 1, right 2. And instead of going up 1 and right 2, you can also go down 1 and left 2. Go down 1, left 2. You're in the same path of points. So if we draw the line connecting all these points, it will look something like this. Now our next equation, again, we're going to look to see if it has y equals, and it does. So we should be able to easily pull out the y-intercept, which is 3, and your slope, which is -2. So I'm going to start with my y-intercept of 3. So I'm going to go on the y-axis, 3. And then my slope is -2/1, so that means down 2 and right 1. So down is negative, left is negative, up is positive, right is positive. So down 2, 1, 2, and right 1, down 2, right 1. I'm going to draw a little circle around to show that there are 2 points at that coordinate. Down 2, right 1, down 2, right 1. You could also, in case that didn't work out, you could also go up 2 and then left. Oh, that's how you spell left 1. So I can go up 2, left 1. And let's draw our line. But we can clearly see that the x value, go on the x-axis to 2, and our y-axis to -1 is our solution. That is what I'm looking for, 2, -1. There's our one solution. On number 2 here, so on our first equation, we do not have it, it does not say y equals. We got to get the y by itself. So I think the easiest way to do this, I typically keep the y, if it's positive, it's a positive y, I keep it there on the same side of the equal sign. I'll move the other terms. Whenever you're moving another term, you're just adding or subtracting. This 5x is positive, so I'm going to subtract 5x. And then we have a -1, so I'm going to add 1. Those are not like terms on the right side. So we have 5, negative 5x. Let me back that up. That looks awful. Negative 5x plus 1. We have our y-intercept is 1, and our slope is negative 5. So I'm going to go on my y-intercept, y-axis up to 1, and then it's negative 5 over 1. So I'm going to go down 5, right 1. You could also go up 5 and left 1. You're going to be off the graph though. There's my first graph. My second graph is already y equals. Awesome. So our y-intercept, and let's do this in blue. Y-intercept is negative 3. The slope, there's a hidden 1 there, so slope is negative 1. We're going to represent that as a fraction, so it's going to be over positive 1. So I'm going to go on the y-axis to negative 3. I'm going to go down 1, right 1, down 1, right 1. Instead, I'm going to go also up 1 and left 1 to stay in the same path. The more points you can put on the graph, the better your graph is going to look. Even though the real reason why we're doing this is just to find the intersection, which we already did, which is at the x value of 1 and the y value of negative 4. 1, negative 4. And there's your coordinate. All right, number 3. I don't see, it's not no y equals here, so we got to solve. I am going to, I think the easiest way is to add 3y because it was negative, and then the y term can be all by itself on one side. And then divide by 3. We get y equals negative x over 3 plus 9 divided by 3 is 3. Don't forget there's a negative 1 here. So my y-intercept is 3. My slope is negative 1 over 3. So I'm going to go up to 3, down 1, right 3. And go down 1, right 3, and I'm off the graph. I'll go from the y-intercept again. I'm going to go up 1, left 3. Up 1, left 3. And let's draw our graph. Let's graph the second equation. 6y equals negative 2x minus 6. So to get the y by itself, it's going to be easy. It's just to multiply by or divide by 6. Negative 2, 6. I'm going to always want to reduce it so I don't have to go down 2 and write 6. So that's a negative 1 over 3. Divide numerator and denominator by 2. And then 6 divided by 6 is 1. So I'm going to go down 1. So my y-intercept is negative 1. My slope is negative 1/3. I'm going to go down 1, right 3. Down 1, right 3. Up 1, left 3. Up 1, left 3. What's happening? Looks to me like these graphs look to be parallel. Take a look at their slopes. Slopes are the same. Y-intercepts are different. Looking back up here, same slope, different y-intercept. That's going to be a no solution. You can actually think about that anyways. Of course it's a no solution. They're never going to cross. So this is a no solution. That is the answer I'm looking for. And last one, number 4. I need to get the equation into y equals mx plus b. Easiest way, I think, is to add 24. We don't have any like terms yet. So I have 12y equals negative 3x plus 24. Divide by 12 on every term. Anytime you multiply or divide, you have to multiply or divide every term. Negative 3/12. That is, divide numerator by 3. Divide the denominator by 3. That's going to be a negative 1 over 4x. 24 divided by 12 is 2. So I have my y-intercept of 2. My slope is negative 1/2. So my y-intercept is 2, and then, or negative 1/4. Down 1, right 4. From the y-intercept, I'm going to go up 1, left 4. There's my line. That represents the y equals negative 1/4 x plus 2. And then let's get the other equation. To solve easiest for y, there's multiple ways, but I think the easiest way is to move the y term. It's negative, so I'm going to make it positive. I'm going to add 4y to the left side. I'm going to divide by 4 to break up the y term and get the y by itself. This is a negative 1. I'm going to pull that actually out. Negative 1/4 x. 8 divided by 4 is 2. So I have my y-intercept of 2, and my slope, slope is negative 1/4. Y-intercept of 2, down 1, right 4, up 1, left 4. Well, they're actually the exact same line. And we can actually look at this by the slopes are exactly the same, and our y-intercepts are exactly the same. So what does that tell us? That is going to be infinite solutions. Infinite solutions. So this is 1E graphing.